Good afternoon, guys. I'm audible. Good. So, everyone, just make yourself comfortable. Have a laptop, it's better so that you can have a big screen in front of you. Okay. Log in the laptop always. That is where I prefer you. Have the data handbook with you. Okay. And notes, calculator, everything. Just take this particular problem. So this particular problem is not specifically a design problem. I mean to say, it is not meant for designing a gap, but it's just a problem where you can get to know the different parameters. Okay, it is just like an introduction problem. Megha. Okay, shall we start the problem? All set?
Writing the question, sir.
Okay. So it takes a lot of time to write the questions since the questions are very much huge in number. I mean, the length of the questions are big. So better what I will do, I'll just post the questions in the Google Classroom. You keep it ready by the next class. Okay? Because you cannot take too much of time in online mode, isn't it? It creates an irritation among yourself only. So I just want to cut short and make it short and sweet, and even you have to learn with full of happiness. So that is my intention. Okay. So I want everyone to be participative while solving the problems. I may ask anyone in between. So if any student fails to answer it, he will be directly marked absent. You can literally see that in the attendance sheet which I have shared to you. Okay. Do not mark attendance till I say you. Okay. So a pair of straight teeth spur gear. So first identify which gear he has given. In a gears problem, so almost you'll be having 80 marks from the gears, okay, out of which only 40 is scoreable. In the sense, module 2 and module 3. So both are of gears, isn't it? In the module 2, you have spur and helical. And similarly, in the module number 3, you have bevel and worm. Okay. So all this carries 20 marks. 20, 20, 20, and 20. Sort of which you have to choose one. Either you can go with spur and leave helical, or go with helical and leave spur, depending upon the question. Okay, which one is easy, you can go with that. Same goes with the bevel. So out of 80, you can attend 40. So 40 marks will be on your hands. Um, so just by learning gas. So that is the greatest advantage you have. And remember, for you, One whole full module is being eliminated. The syllabus is totally cut short for you. Okay, that's the happiest part. Okay. So first identify the gear as I said you. So which gear is given here? Which pair is being given? Whether it is spur, helical, worm, or bevel.
Spur gear.
It's a spur gear, isn't it? Is used to transmit the power. So power is being given, just write it down. P is equals to 20 kilowatts. Next, when the pinion rotates at 300 RPM. So I told you, pinion is a bigger wheel or smaller wheel?
Smaller.
It's a smaller. So just write here gear and here as the pinion. Okay, below that you can just write the parameters to avoid the confusion. The pinion rotates at 300 RPM. So just write 300 RPM just below the pinion there. The velocity ratio is 3:1, so I value is being given. I is used to indicate the velocity ratio, and it is given as 3:1. So I value is 3:1 given that. Allowable static stress for the pinion. Allowable static stress for the pinion, he says. So it's a pinion parameter. Okay. So allowable static stress is nothing but the design stress, and it's for the pinion. So how much he has given? The value allowable static stress for the pinion gear material is, okay, gear, pinion and gear. So both he has given sigma D, allowable static stress for pinion and gear, both he has given. For pinion, it is how much? It is 120 megapascal, and for the gear material is 100 megapascal respectively. The pinion has 15 teeth. So pinion in the sense, again, I just draw a line there so that it bifurcates everything. Okay, good. Now, the pinion has 100 teeth. So this is NP, I could write it as. So it is speed of the pinion. Similarly, number of teeth on the pinion is given. How much it is? It is 15 teeth. That's great. And the face, 15 teeth, and its face width is 10 times the module. So look at this parameter, what he has given. The face width is 10 times the module, he says. Face width is 10 times the module. So what is this parameter given? Face width is indicated by small b. All of you just look into that this thing, data handbook, and say me in which notation the face width is being denoted in case of a data handbook. So refer your data handbook in the first page, identify the face width there. Where is the face width? So you can see there the face width is being represented how? It's in mm, so it's in b. So b is nothing but 10 times the module, so 10 times of m. So that is what he has given. Very good. Next, 10 times the module, the tooth form factor. So form factor y, form factor y, he has given as what? 0.154 minus 0.912 divided by z. So this particular equation for the form factor he has given. And for the velocity factor, next is he has given as the velocity factor. So velocity factor is nothing but CV. He has given in terms of equation there, that is 3 divided by 3 plus V. You can find this type of equations in your data handbooks also. There are also batch formula. You'll get to know about this, no issue. Where velocity is in meters per second, he says. Okay, that's great. So what you are required to determine from this? So to find, what do you have to find? What do you have to find here?
Module.
You are required to find the module. So M is being questioned. Next, phase width B is being questioned. Next, PCD of the gas. PCD in the sense, pitch circle diameter of the gas. You have to find out the standpoint of strength only. So with respect to strength, you have to find out the PCD. So this is the problem which is given. Any doubts in the data? Any doubts in the data? Shall we proceed to the solution then? Okay. So shall we proceed to the solution then? I'm audible. Just
Yes, sir.
okay. Is the screen visible?
Yes, sir.
Okay. Good. Rishikesh. Now, so before any problems on gas, first you have to identify the weaker section. So what are the two different sections you have? One is the gear which is you are having, and other one is the pinion which you are having. According to you, which could be the weaker?
Pinion.
So which would be the weaker section? Pinion would be the weaker section because it takes the more load, isn't it? Yes, it is a weaker section. But the thing is, you have to prove numerically with the parameters you have to prove. Sometimes if the pinion material is so strong and the gear material is very much soft, the gear could become the weaker part. Getting my point? So it is always better to have a check. So first identify, I will go with solution now. Solution. So first step is what? Identifying the weaker part. Okay, so identifying the weaker part. How do you do that? You would do this based on the strength factor. So carefully observe all the steps. These are very important. So you will define the strength factor. So what is the strength factor? Strength factor is given as the design stress multiplied by form factor. So I would say this particular thing as my strength factor. Getting my point? So this I have to define it for both the things, isn't it? First for the pinion and for the gap. We will do it. So first we will define it for the pinion. Okay. For pinion, do I have the design stress for both things? Let me check. Do I have it? Yes, I have the design stress for gear as well as I have the design stress for the pinion, isn't it? It's already available. Now, I have to have the form factors now, isn't it? To calculate this thing. So we do that. So pinion, for pinion it is Design stress is how much for the pinion? It is 120. Okay. 120 into 120 into, he has given the equation for y, I guess. Pick that. It is y is equals to 0.154, 0.154 minus 0.912 divided by z. This is for the pinion, right? Do I have the value of zp? Kindly interact with me, guys. It would make me solving the problem in a good speed. And it would help me also, rather than looking and scrolling my screen every time. Do I have the value of ZP?
15.
15, that's great. Do not use the chat box, guys, since I will be solving, no? It's better that you talk to me, okay? So at base 15 here is given. So no issue in calculating the strength factor for the pinion, I guess. Can you give me the value? Strength factor of the
11.184.
pinion. 11.184 megapascal. Now you go for the gear. Gear, the design stress which is given as how much?
100.
100. So 100 into 0.154 minus 0.912 divided by ZP it is. ZP in the sense now it is ZG. So do I have the number of teeth on the gear?
No.
So how to do that? On the other hand, you can just write here I is equals to velocity ratio is equals to Zg divided by Zp, number of gears on the number of teeth on the gear and number of teeth on the pinion. From this, you can calculate number of teeth on the gear, that is equal to I times of Zp. So I, how much is the I? Velocity ratio?
3:1.
So 3 cross ZP value is 15, so it is 45 is the number of teeth now. I would just replace this to 45. Now, what would be the strength factor of the gear? Hello? Hello?
Good afternoon, sir.
Good afternoon.
Sir, I am Syed Anwar speaking.
Yes, Syed.
Sir, tomorrow onwards, lockdown is there.
Who told? Who told? Okay, so just got the news that there is lockdown from tomorrow in Karnataka. When this corona ends, God knows, seriously. Fed up. Strength factor for gear. How much is the strength factor for gear?
13.373.
13.3.
Okay, so it is 13.3 megapascal. Now compare the values of strength factor of pinion and strength factor of gear. So which one is lowest? Which one is a lower value?
Opinion.
Opinion.
Pinion is a more value. Okay, since are you able to see the screen, guys?
Yes.
Good. So strength factor for pinion is lesser than strength factor of gear. We would consider pinion as a weaker part. Got it? Yes? So now every calculation will be based on the pinion. Okay, got it? Any doubts, guys? Shall we move on?
Yes, sir.
Okay. Now, first thing what you have to find is, I guess it is module, isn't it? So look into the data handbook. Can I get a formula through which I can calculate the module? Can you just refer me something using the data handbook? Just look there. Any
12.1
formula
D.
to calculate in Spur gear, Okay, look for in Spur gear. Everything will be in the data handbook itself. Just check there.
1 by PD. M is equal to 1 by PD.
M is equals to, where did you get the equation? Can you just tell me the page number and
12.1
equation
D.
number?
12.1D, page number 203.
12.1D. Okay, you don't know the pitch circle diameter, isn't it? Nor you don't know the circular pitch or diametrical pitch. So it's waste of using it, isn't it? Next, any other provisions? Any other provision, guys? Look into your data handbooks. No idea? Yes, Fawaz? Arvin, Rishikesh, Ashil, Harsha.
Yes, sir.
Hmm. How to find out yum now?
Sir, ನಾ ಈಗ ಎಂಟ್ರಿ ಹೊಡ್ದದ್ದು ಸರ್.
Absent.
ಸರ್ ಅಬ್ಸೆಂಟ್ ಅಲ್ಲ,
Hmm.
ಈಗ ಬಂದದಷ್ಟೇ. ನಾನು ಎಂತ ಫೈನ್ ಮಾಡ್ಲಿಕ್ಕೆ ಈಗ?
ಎಂತ ಫೈನ್ ಮಾಡ್ಲಿಕ್ಕೆ ಅಂತಂದ್ರೆ ನೀನು ಹೇಳಿ ಅರ್ಧ ಪ್ರಾಬ್ಲಮ್ ಮುಗ್ದೋಗಿದೆ.
ಸರ್ ಸಾರಿ ಸರ್, ನಾ ಈಗ ಬಂದದಷ್ಟೇ ಸರ್.
Hmm. Be on time.
ಓಕೆ ಓಕೆ.
Next, anyone? Arvin? Muhammad Gauss. Muhammad Gauss absent.
ಸರ್ ಅಲ್ಲಿ ಪಿಚ್ ಸರ್ಕಲ್ ಮಾಡ್ಬೋದಲ್ಲ ಸರ್, ಪಿ ಇಸ್ ಈಕ್ವಲ್ ಟು ಪೈ ಎಂ.
ಯಾವುದು?
We need module for that.
Hmm. So that is
Yes,
how.
sir.
Arvind, just look. I want the formula. I want the data from the data handbook. I would never give you the data. That is why I have not even said you the design procedure, how to do it, or I would not even taught you the theory of the design procedure, not even given you to write the design procedure. Directly we have jumped into problems. So every student of this class are of the caliber that they can solve the problem without the aid of nothing but just by the data handbook. So you know how to use it. Only with help of the data handbook you can solve everything. So that particular skill, that particular caliber, I wanted to be developed in yourself. So that is why I'm just making you to search for everything. Search and learn. Search and learn. Yes. Any other options, Navneet? Radvik? Yes, guys. Any other solution? Riven? Ratvik?
K is equal to B by M.
Hmm? Yes?
K is equal to B by M.
A is equals to B by M. What is A? What is A?
K, sir.
Center
Load stress.
distance.
Center distance ilvala ನನ್ನ ಹತ್ರ. I don't have it.
Load stress factor, sir.
So again, check the Levy's equation for beam strength of a tooth. There you can find something. ಜಾಸ್ತಿ
K is equal
ಪ್ಯಾರಾಮೀಟರ್ಸ್
to B by M.
ಜಾಸ್ತಿ ಪ್ಯಾರಾಮೀಟರ್ಸ್ ಇದಾವೆ, ಹಾಗಾಗಿ ಇದು ಬೇಡ ಅನಿಸ್ತಾ ಇದೆ ಅಲ್ಲ ನಿಮಗೆ? Since it has lot many of parameters, that is why you're treating this cannot be used for the calculation, isn't it? But the thing is, this one particular equation is most usable in this particular chapter, Levy's equation. Remember this. Pick that particular equation and sing. Okay, what is that equation? M is equal to M is equal to, anyone? Cube root of anyone just help me with the equation, man. Otherwise, I have to look here and write.
2mt
2 times of mt divided
divided
by
sigma d
sigma d
cv
cv
kyz.
kyz. Lot many parameters are there. Okay, we'll see one by one. Just always, if there is a big formula, always have a habit of writing a line beside the formula like this and just write all the parameters, whatever you know. What do you mean by MT? Whether he has given any information about MT over there?
Transmitted torque.
So MT is nothing but torque, isn't it? In Newton mm, I guess, correct?
Yes, sir.
Newton mm. So he has given clearly here. Okay, it should be Newton mm. So how to calculate torque? So for that I have a formula. P is equals to 2 pi nt by 60. Correct?
Yes, sir.
Yes, sir.
Do I have the power? Do I
Yes.
have the power given?
Yes,
How
sir.
much is the
20
power?
kilowatt. 20 kilowatt.
So it is 20 into 10 to the power of 3. That is equals to 2 pi. Now, n in the sense which you have to take. Whether you have to take for the
300
gear or
RPM.
you have to take for the pinion.
Pinion.
Pinion, very good. Always take the pinion parameters. Why? Because you have decided the pinion to be the weaker part. Wherever the parameter is being asked, take the pinion parameter just because you have decided it to be a weaker part. Now, what is the speed of the pinion then?
300
300.
RPM.
So it's a 300 RPM. So now torque is being is changed the notation. Just it has been changed to MT now, isn't it? So it is MT cross 60. From this, can I have the value of the torque?
Six 36.61.
36. And what unit of this?
Newton millimeter.
Yes?
Newton mm.
Kilonewton.
No.
Newton
So it
millimeter.
would be in Newton meters, guys. Please do take care. Okay, so it would be in Newton meters. What you have to do so that to convert it into Newton mm? What I have to do?
Into 10 to the power 3.
So just multiply it by 10 to the power of 3 to convert into Newton mm. So I have the value of MT now, isn't it? So I would just take this value and write here it is 636.61 cross 10 to the power of 3 in the desired unit which is being asked, the Newton mm. That's great. Next, do I have the design stress? Do I have the design stress?
Yes, sir. 120
So
MPa.
again, which I have to take? Whether should I take it for the gear or should I take it for the pinion?
Pinion.
Pinion, isn't it? So I would take for the pinion. How much is the valve left?
120 MPa.
120 MPa. Okay, that's great. In the same unit, it has to be substituted there. Any information given in the data handbook? He says,
No, sir.
just look here. He says sigma d is allowable static stress, table number 12.7, correct? So just go for the table number 12.7. Give me the page number. 12.7 table number. If you give me the page number, it would be for me to scroll.
115.
How much?
205.
What is page number? The table, guys.
234.
234. So that is what I have needed. So 234. 33. Yes. This is the page, I guess, right? 12.7. So here it is. Okay. Now, see, allowable stress, if you descend upon, suppose in the problem, if you has given the pinion material is phosphorus gear bronze, then you have to take this particular value. Correct? So this is the table through which you can take the design stress if it is not given. Since it is given in the problem, my intention is in what unit I have to substitute. So what is the unit that he has mentioned here? Yes, what is the unit that he has mentioned here? It's mega Newton meter square. That means mega Newton per meter square. Newton per meter square is what? Megapascals. Have to directly substitute it in megapascal. Got it? Got it, everyone?
Yes, sir.
Yes, sir.
So this is how you hunt your data handbook. Okay, now come back to it. Come back to that. Yes. Now, all of you in your data handbook, what you do for safer side, just write there in using a pencil, substitute in megapascal. Okay, it would be easy for you in the next time. You need not look into the table again and descend upon the units. Rather, you can just look here and decide. Okay. Is that clear?
Yes, sir.
Okay then. Now, we shall go back to the problem now. So 120 megapascal, it is in megapascal, no need to change the units now. CV value. Now we have to get to know the CV value. Any ways that I can get the CV values? Any way? Do I have any way? I think CV equation is being given in the problem, I guess, right?
Yes, sir.
Yes, sir.
So now just copy that particular thing and just paste it here. Okay. For that, I think you require V value for that, isn't it? You have V to calculate CV?
No.
No. So the formula for V is that available in the data handbook? Just check. Formula for V. Okay. It's not given, so kindly note it down. Okay. It's just simple formula, basic level formula. It is pi dn by 60. Okay. So what is V? In the notes, you have to just mark like this. Mark a circle. Just write need to be remembered. Just add a sentence like that. It would be easy for you. Okay. Now, to calculate this d, again, which all parameters do I require? Diameter and the speed, isn't it? So, which diameter should I consider, or which this thing? Which speed should I consider? Guys, should I
Yes, sir.
consider pinion or should I consider the gear? Pinion, is it? So I would just write pi dp cross np divided by 60. Do I have the value of dp? Do I have the value of dp? I don't have it,
No,
isn't
sir.
it? So what you have to do is you have to go by this particular method. Go for this equation here at the start, basic level equation. Here he has specified that m is equals to d by z, correct? I know you don't even have the module, but just take that particular equation where it says dp is equal to m times of zp. So module is not being calculated. Keep it as it is. But what about zp? You have, I guess, right? How much is the value of zp?
15.
15. So substitute in this. So it is pi cross dp is m cross 15 cross p, speed of the pinion. I guess you know the speed of the pinion.
300.
So it's 300 divided by 60. Just multiply all the numericals and give me the value in terms of m, meters per second.
235.61 m.
2 how much?
235.61.
235.6 m.
Yes, sir.
Okay. Are you sure about this value? Yes, it could be 235.
Two 235.61, sir.
Okay, 235.61 m. Okay. Now, look here. So whatever the value you are saying, it is in mm per second. Okay. So this value, whatever you have got is mm per second. Now convert it into meters per second. How do you do that? Divide it by 1000, so it becomes 0.235 m in meters per second. So this is the final value. Okay. Now, where were we? Okay. So we need to calculate CV now. Go for CV is equal to 3 divided by 3 plus P, that is 3 divided by 3 plus 0.235 m. Keep it as such and just write here. So can you just say me the value? 3 divided by 3 plus 3 divided by 3 plus 0.235 m. Okay, m is smaller here. I'll just change this. Okay. Next, CV ಆಯ್ತಪ್ಪ. ಇನ್ನೇನು ಉಳಿದಿದೆ? K. What is value of K there?
B by M.
B by M.
So B by M. So B by M, any information given in the problem?
B is known.
Yes?
10.
B is
Just
equal to
look
10
for the
M.
given data. Is equals to 10. So this particular thing is given in the problem. Okay, next. K ಆಯ್ತಪ್ಪ. ಇನ್ನು ಎರಡಿದೆ. What is this capital Y? Just look into the data handbook. What is that?
IY.
Capital
Y and small y.
5 times of Y. Okay, good. So it is nothing but it is 5 times of the form factor. So 5 times of the sense it is 5 times of Y you have calculated for the opinion, I guess, right? So Y
Yes,
value
sir.
is this value, correct? Take that particular value there and give me the value of Y.
Point 0932.
0.0932.
0932.
So this it is Z of the opinion now. Number of teeth on the opinion. How much?
$15.
I want others to answer. Mohammed goes, yes, goes. How much? 15, isn't it? Now, so all the parameters you have listed one by one, guys, for using this particular formula. Okay. Now substitute all these parameters in the main equation. It gives a big amount of equation. I need your help in this. Mohammed sir, can you just help me out to write that equation here?
Okay, sir.
It is m is equal to
Cube root of
cubed root of, correct? In the numerator.
2 into
2 into
636.61.
636.62
61 into 10 to the power 3, sir.
into 10 to the power of 3 divided by
Sigma D is 120
sigma d is 120 cross C
into 3 divided by
3 divided by
3 plus 0.235.
3 plus
0.235 M.
0.235 m cross
10.
cross
10, sir.
10 cross
Pi into
pi into
0.0932
0.0932
into 15.
into 15. So you have to solve this equation. So one simple suggestion is transfer the cube to the either side, sorry, square root to the either side becomes m cube and all this particular equation. I have taught you in class, hopefully in the BTD, that you can use equation number 5 in your calculator to calculate this sort of expressions directly. How many of you remember it? Raise your hands. So you can use your calculator to solve this particular expression directly. Okay, type all the same equation, similar fashion, using x. Wherever there is m, type x there. Okay, just try to solve this. How many know to solve this particular thing using calculator?
7.23.
7.23. Excellent, excellent, Anush. Very good. That's the right answer. Even textbook says the same thing. It is 7.23. Textbook says it as 7.24. Excellent, excellent value. How many of you know to using calculator this big expression? Just raise your hands. Let me see. Okay. Good. Good. Most of you know it. That's a good thing. Okay. Now, whatever you have got, this particular module, 7.23, always remember, module is a whole number. It cannot be a decimal. You need to standardize this particular thing. Okay. So how to standardize? Now, all of you go for whole number. Now, just write here one sentence. It's not m cube, by the way, it's just m. Okay. Standardizing the obtained module using table number 12.2, which is in page number 229. Okay, just go for that table number. Which is this? Everyone got the table with you? Like guys, are you able to hear me?
Yes, sir.
Did you get this table?
Yes.
Yes, sir.
Okay. So this, but he says, just read the line he has given. Module given table may apply for the spur and helical gas. He says, okay. So for spur and helical gas without any tension, you can use this particular table directly. Now, what is your value obtained?
7.23.
It is 7.23. Is it? We have to go for the standardization. And just check. There are how many columns here? 3 different columns. One is preferred. Okay. Second one is choice number 2 and choice number 3. Why are these different? The first one is preferred in the sense the preference level has to be, this is available, you have to take this. If this is not available in your shop, in your workshop, then you have to go for the choice number 2. If choice number is also not available in your workshop, then you have to go for the choice number 3. Got it, everyone? Is this clear?
Yes, sir.
So always you have to go for preferred, then you have to go for choice, and then you have to for the choice 3. So for our problems, you are not an industrial person, isn't it? You are just for the solving the problems. For solving the problems, always go with preferred. That's enough for us. Okay, go with the preferred one. In preferred column, 6 is available and 8 is available. Which module should I take? Should I take it as 6 or should I take it as 8?
8.
Why 8? Why not 6?
8 is near to the value which we got.
Okay. You came in that sense, you were that
We should always take the largest
came,
number.
Exactly, Vikit. So what you have to do, you have to select always a larger number, because when you select a larger number, it accounts for more and more factor of safety. Taking that into concern, I would take which value to be standardized? I would take 8 as my module. So what I would do? So I would just standardize my module to 8 mm. Navva, class join. Okay. So module is being finished. What is the second part that is being asked? What is the second part that is asked?
Face width.
Face width. So face width, he has given, I guess, in the given data, the face width to module ratio is, so module is 8 in the sense face width is m times 10. So it is 8 times 10. So it is how much? 80. Correct? So next, third one. What is the third one he has asked? Guys,
PCD.
what is the third one he has asked?
PCD.
So PCD, you go for the data handbook. At the start of the page itself, you can find D is equals to M cross, right? Okay, now calculate for the pinion and for the gear separately. So it is dP is equals to M cross ZP. Remember, module for pinion as well as the, it's a combination thing, individual thing. Okay, so dz is equals to m cross zg. Substitute the values. So m is 8 cross zp is how much? And zg is how much? Number of teeths.
15 and 45.
15 and 45. Just write the values, whatever you have got. What are the values? 8, 15s, 15 8s.
120, sir.
120. and 45 cross 8.
360.
So
360.
20, so it is 360 mm. Anything else is required to be calculated in this particular problem?
No, sir.
Does whatever
No,
was
sir.
asked, everything is calculated? Okay. So here ends your particular problem. Everyone understood problem?
Yes, sir.
So the main heart of the problem is this particular equation where we have spent a lot many of time to understand each and every parameter, isn't it? From the next problem, it would go in a faster pace since every parameter is known to you. This was the first problem. So understanding all the parameters, it would take time. Okay, that's a great news, and all of you just start to mark your attendance. Within 1 minute, I would just take the data from there. And just stop.